Let's B part 4, lecture 17, D4, Noether theorem, spatial translation. See? So, attention now, you see, don't skip, you see, the lectures. See, otherwise you will not understand. You have to follow, and in this case, one lecture is after the other. You have to understand the previous one, you see, just to follow what I'm doing over here. So, from the last lecture, 17D3, you see, we reached, you see, to this relation here. This is variation of the Lagrangian density, okay? This is partial respect to xj in this case, so it's partial j. This relation we obtained from lecture 17D3. I just wrote over here. And attention now, you see, this is a spatial translation. So this case is phi, okay? The function of the x1, x2, and x3. You see, no time is involved, explicitly, you see. So the variation of phi is minus, you see, epsilon k partial respect to xk of phi. So this is a characteristic of a spatial translation. So for the spatial translation, the variation of the coordinates contributes to the change in the Lagrangian density, and we write, you see, variation of L, you see this L here, okay, there's a phi prime, okay, and partial j phi prime. This is a translation, okay, to the prime, the coordinate of prime axis. So this is the variations is this minus this over here. You see, that's x. This is x prime. Now we consider passive transformation, where the coordinates are fixed, but the field change as partial phi is equal minus epsilon k partial respect to k and phi. Just over here, you see, as I pointed out and I emphasize, this is the same x, same function at the same point, you see. So I can write over here, you see, this is I compute now, this I can swap, you see, this derivative over here, this is partial respect to j of delta phi. So this is equal, in this case, you see, you just swap over here, then you can obtain this relationship. So this case, the variation, you see, you just partial L respect to phi minus epsilon k, see, partial k respect to phi plus partial L respect to this one. I just substitute, you see, here and here, okay, this relation over here, you see, that they say the passive, you see, passive transformation, I just look at the same x, see, the same point x, x1, x2, and x3. So then I can write, I put the minus sign over here, okay, then I can write over here in terms of epsilon k. This is the relation 1. Now it's interesting. Oh, look, attention only on this term over here. You see, I brought this term just over here. You see, this I call u, this is v prime. Prime here represent the jth coordinates. You see, that's a v prime. Now I can use the product rule, okay? So u is this value, u prime is just a partial respect to j, you see, of u. And v, in this case, is the integral of v prime. You see, this I have derivative, So the integral just leads to partial of k respect to phi. That's quite easy. You see? Now apply, in this case, the product rule, or Leibniz rule. You see? So this I just substitute. You see the colors over here. You see, that's just to help to understand, because you see the notation is quite confused, but I'm using colors. So no problem. This is uv prime, that the product, okay, derivative of the product, that minus u prime v. You see? That's a product rule. I call this capital B, red, capital A, and capital C. This is equation 2. So I will substitute, you see, A minus C is equation 2 into equation 1. This leads to, you just copy, you see, you copy from equation 1, you see, from here, I just wrote over there. I substitute uv prime by this, in this case, uv prime minus u prime v. You just plug on here. That's why I wrote just this term over there. You see, this capital A minus capital C, okay? It just corresponds to capital B, you see, over here. See this capital B. So, on the other hand, for Euler-Lagrangian equations, I can relate this one to partial of L respect to phi. This equation 4, okay? Now substitute 4 into 3. This leads to, just copy, you see? This leads to this relation here. I just plug, you see? You see the green one here? That's a green one. I just plug the green one over there. So it's quite easy. You see the green one over here. You see? Now this will cancel with that. So the result is the variation L at point x, not point x prime, is equal minus epsilon k. Now this is the divergence of this quantity over here, you see? So that's a very important result that will follow, in this case, okay, will be developed now from lecture 17d5. I just start from here, okay? So the objective is to lead to the Noether current, the Noether theorem, then they have the Noether current. But attention now, the hypothesis is spatial translation, is the symmetry. I will show that this implies a conservation of energy momentum. You see, as you see, the next 17d5. Okay, that's it.